All right, thank you for joining us today. And in this video, we are going to use what? Leibniz rule, right? So in the previous video, we started with the idea of applying the Leibniz rule, and then I said it is the idea of rethinking of um, differentiation versus what integration. Now here we want to apply the Leibniz rule to show that this is equal to this. Good. So the idea with the Leibniz rule is we want to integrate the function, but what we want to do is we want to take partial derivative first before what we integrate the function. So the first thing that I'm going to do here is I'll let I to be equal to my integration. So that is the first thing that I'm doing, right? That's the first thing that I'm doing. Now, when I do that, now I ask myself, what variable am I going to take the derivative with respect to? So here is the case, they didn't show us anything here, right? So as I said, you check the function that you are integrating and what you are integrating with respect to. So we are integrating with respect to t, so it means that t here, t here, t here. So the only variable here is the b, right? So it means that we can make this one depend on b. So it means that our first partial derivative should be on b. So we are going to take partial derivative with respect to what? B. Good. So this is what we are going to have. So now when I differentiate this, I'm going to have prime b, which is equal to integration from 0 to infinity. Then I'll take the partial derivative with respect to b of e to the power minus t minus e to the power minus bt divided by t dt. So let's do the integration. Now what I can do here is I'm integrating with respect to b. So since this one is dividing, it's like constant, so I can factor it out, and then I will have e minus bt dt. So what am I going to get when I do the integration? Now I need to integrate this. There is no b inside this, so it's a constant. And when I differentiate a constant, I get what? 0. But here there is a b, so I need to do that. So when I'm differentiating this, I'll maintain the function times, then I'll differentiate the top. Remember, we are differentiating the top with respect to b. So I'm going to have minus t times ln e, which is 1. So I'll have something like this. Then what can I do here? T will cancel t. Minus minus is positive. So it means that the function will be left with integration from 0 to infinity e to the power minus bt dt. Wow. So this is what is going to be left for us as I prime of b. Now when I integrate this is an exponential function, right? So for us to integrate this, I maintain the function, then I divide it by the derivative of the exponent. But don't forget, this one we differentiated it by b, but this one we are integrating by what? By t. So this is going to give us minus b. So I'm going to differentiate this one by t, and I'll get this from 0 to what? Infinity. When I plug them inside, don't forget infinity and 0 are for t. So when I plug it inside, I have negative infinity divided by minus b, right? Then minus, when I plug in 0, I'll have e to the power 0 divided by minus b. How did I get that? When I plug infinity here, b times infinity will still be infinity, so minus infinity. And when I plug 0 here, everything here times 0 will be 0, so I'll have something here. So it means that what is infinity What is e to the power negative infinity? It's 0. So this one will be 0 divided by this, which will be 0. And then this one will be 1. E to the power 0 is 1. And then negative will be positive. So we are going to have 1 over b. 1 over b. So let me go to the next page. We have ib to be equal to 1 over what b. Now the question that we are working on, even we know that we need to look for lane b. And as we said as we saw from the previous video, we saw that when we had the I prime, we integrated. So what you need to do is we need to integrate this function with respect to what b. So now let's integrate this with respect to b, integrating this with respect to b. So this will be I of b plus, when I integrate 1 over something with respect to b, I'm going to have ln b plus c. But the thing is, we need to show that this is equal to what? Ln b, right? And don't forget, so we want to show that this is equal to ln b, and this is equal to ib. So the ib is what we've got in here. So the next thing to do is we need to make sure that this guy here, we need to find a constant, and definitely it should be 0, because what we are proving is just ln b. So I'm going to pick this one. Let me even pick this one, and we are going to do something similar to what we did in the previous video, where we need to choose alpha. So here what we need to do is we need to choose b such that this will go to 0. So always, if you want to choose b, look at the function, look at where your b is. I can see that my b is only here, and I'm going to subtract this one from this. And this function that I'm going to subtract is just e to the power what? Minus t. So for this one to be e to the power minus t, so that this minus t to be 0, then b should be what? 1. So that when b is 1, I'll have e to the power minus t, e to the power minus t, then the top will be 0, making everything 0. So this one will help us to get our initial condition. I of 1 is equal to 0. Because when I put 1 here, I put 1 here, this term now becomes the same and it gets to 0. 0 divided by this, and when I integrate everything here, it gets to 0. So now I have I of 0 to be equal to I of 1 to be equal to 1 ln 1 plus c. I of 1 is 0, ln 1 is 0 plus c, and c will be equal to 0. So I of 1 is 0 from here, and ln 1 is also 0. So now we can see that IB is equal to ln b, and we saw there was a condition saying this. So the domain of the ln function is all positive value of b. We cannot have negative, even we cannot have 0, because when I put 0 here, ln 0 is negative what? Infinity. So this is how we are going through, like this is how we are going to get the solution. So first I picked this one to be equal to I, then I looked for my constant variable, which was not depending on t, and we saw that it was b, and I placed it here. And then the b, as soon as I find my constant variable that I need to differentiate with respect to, I take the partial derivative on both sides, I swap the integrations, I do some simplification, and then I integrated. When I integrated, I had this one to be equal to 1 over b, right? But what we are looking for is IB. So I need to integrate both sides, and then I have something like this. And we said, as soon as you get to your last step that you want to find a constant, pick the main question given to you, right? And look for something that you are going to substitute it inside the function so that this one gets 0. And here we saw that when b is 1, this one gets 0. So that's the reason why we had the initial condition. And we use that one to solve this one. and therefore this one is equal to this, as suggested from there. So if you have any question, you can drop it in the comment section, and then I'll do my best to explain them to you. See you in the next video.